Yes, hi guys. Dear folks, today I will talk about Wallis formula. Okay, in the same topic, reduction formula. Further, I will take the topic. Okay, in the previous lecture, I talked about reduction formula for sin nx, sin raised power nx, and cos raised power nx. Okay, so questions I tracked the basis of those two reduction formula. Now I will discuss about what is Wallis formula. Let me talk about what is Wallis formula. Wallis formula. Okay, I'm sorry, formula. What I'm writing here is Wallis formula. What is Wallis formula? He gave two values sin and x, dx 0 to pi by 2 limits. He gave some formula for this. That what is the value of this? This is the first, and second is 0 to 0 to pi by 2, and cos raised power nx into dx. For these two, reduction formula, he gave when definite integral is to be calculated, limits from 0 to pi by 2, and what is the formula for that? That shortcut formula will be used, okay? Or that reduction formula will be used, and these formulas are used then to calculate the other kind of formula in which the limits are 0 to pi by 2. Okay, so who was Wallis, and Wallis gave this formula in case of integrals, in case of calculus, integral calculus in this case. Okay, who was John Wallis? John Wallis, a brief introduction that I always put some contribution, whatever contribution mathematicians have given, a small part to a larger part. I always discuss about them, their contribution in the field of this, their introduction, their brief history, so that people can understand that how many mathematicians have come up on how they have contributed in the field of mathematics. Okay, I just not eulogize them, but I just want to share with the students this kind of information so that the students have a deep interest in the field of mathematics. Okay, I want to just turn the students' interest in the field of mathematics, because there are certain students I found they are scared of mathematics. Okay, so the people who have contributed, the mathematicians who have contributed in the field of mathematics, so brief history of them may create some interest in students' mind. That is my main objective here. Okay, main motive here. But let me talk about John Wallis. John Wallis. Okay, this is John Wallis. John Wallis. Right. Okay. Was born on 3rd December or December 3. Was born on 3rd December. On 3rd December. Born on, let me write here. Born on 3rd December 1616. Okay. A British mathematician at in Britain he born. Yeah, he was a British mathematician. Like born on 3rd December, and he died on November 8th or 8th November. 8th November 1703. Okay, in the age of 86. Okay, in the age of 86. So this is his brief introduction regarding his time of birth and the date and death of birth. Okay, or date of his death. What is this? 8th December. Yes, 8th November 1703. 1703. Okay, and born on 3rd December 16th. 16. That is how 86 years he was. Okay, when he died. One thing, he was clergyman also. He was a clergyman. Okay, as well as his contribution in mathematics. Okay, let me talk about his contribution in mathematics. What is his contribution? He was a British mathematician. He was a British, basically an English person. Okay, a British mathematician. He is a British mathematician. British mathematician, a clergyman, a clergyman as well as mathematician. His contribution in theology also is there, mathematician. Okay, a clergyman as well as a mathematician. Okay, his contribution in theology as well as in field of mathematics. So what is his contribution? I am not going to talk about his contribution in theology, but he was also a theologist. He wrote a number of articles, wrote a number of books in theology also. Okay, so my main aim just to talk about his contribution in field of mathematics. What is contribution in mathematics? Okay. In field of mathematics. Number one, his contribution in the field of mathematics in geometry. Let me write here geometry. He has contributed calculus. Okay, even conic section. I mean calculus, conic section. He has conic section also. He talked about. Okay, logic. Geometry I have taken infinitesimal series or infinite series. Infinite series. He has number of particles in infinite series. Okay, or infinitesimal calculus. He introduced the infinitesimal. Let me write here. Infinitesimal calculus. Okay, infinitesimal calculus, and he gave the symbol for infinite. Okay, he used first time the symbol infinite this for representing for 1 upon 0 or infinity. For infinity, okay, for infinity, use this symbol first time. So his contribution, I mean, introduced x 0 equal to 1 upon or x minus 1 equal to, his symbols are x minus 1 or 1 upon x. Okay, then x raised power 1 upon n. We use this symbol nth root of x, etc. Okay, and infinity also 1.0 is infinity. We first introduced infinity. Number of symbolical presentation also he used. Okay, lot of other things. I mean, mostly these radical signs. One nth root. Okay, square root. Like this x raised power 1.2. Square root of this x. Okay, etc. And even he used how to represent the integers of the numbers on number line. He introduced the number line system. Okay, in his book Mathematica of Opera Mathematica, in 1695 he wrote a book. His book. Okay, in his book Opera Mathematica. Opera Mathematica 1695. Here given all these things, symbols he used, and he introduced the presentation of numbers. Presentation of numbers on number line. Very important, number line, which we study these days. How the number line? The negative integers he presented like 0 here, then 1 positive integers, 2 at the same distance. Okay, the back side is -1. Negative integers also present. This number line he introduced. His contributions are many. Just a brief introduction to Wallis, John Wallis. John Wallis, his name was John Wallis. Okay, John Wallis. John Wallis is not, I mean, Wallis, not Wallis, but it's John Wallis. John Wallis. John Wallis. John Wallis. John Wallis is a great mathematician here. Contributed a lot of things in symbolic representation, in conic section, calculus, in geometry as well as in logic. Okay, he was a multi-dimensional personality. Okay, now let me talk about the main objective of today. Main topic is Wallis formula. What is Wallis formula then, and what does he mean by this, and how it represents the shortcut for reduction formula. Reduction formula, further introduction to reduction formula. I'm talking about the Wallis formula. They are known as Wallis formula. Let me take the first one. We know that sine of integration sine of nx into dx is whatever is this. What is this? We have just taken this as it is minus cos x into the I'm writing the result of this minus cos x and sine whole power n minus 1 x divided by n here plus n minus 1 upon n sine of integration into sine whole power n minus 2 x into dx. This was there. It can be written as symbolically we can write that this is Sn and here it is equal to minus cos x sine n minus 1. This is Sn minus 1 here Sn minus 1 divided by this is n plus n minus 1 upon n. This value is Sn minus 2. Okay, we can write symbolically like this. Now what is the result of this? If I use the infinity sign, these limits, what is the value of 0 to pi by 2? Okay, sine nx into dx then equal to how much? If I apply the limits here, let me apply the limits. Cos of x sine of n minus x n minus 1 for here it is n minus 1 x upon n. If I apply the limit 0 to pi by 2, now in both the cases this will be 0. How? This is pi by 2. If I substitute the upper limit cos pi by 2 is 0. In case of 0, and so it is 0. When I substitute the upper limit, it is 0. When I substitute 0, then sin x is 0, sin 0 is 0. In both the cases, the value of this in case of limits is 0. Then what is the final value? This is n minus 1 on n into sine n minus 2, or limits are to apply here again. Those limits 0 to, let me write here, 0 to infinity. Here let me write the complete value. This is sine of integration, sine of n minus 2 into x into dx, limit 0 to pi by 2. What do we get here? In this way, if I find out again sine of integration 0 to n, pi by 2, sine whole power n minus 2 x into dx. This will again give us what? Minus cos x sine of n minus, this is n minus 3 will be there. So only one power lesser than this. Okay. This is n minus 1, here it will be n minus 2, n minus 3 here into x divided by n minus 2, n minus 2 will come here. And plus here it will be n minus 3. Okay. Because only is n minus 3 divided by n minus 2. Here n minus 2 will come out. So this is what? 0 to infinity, pi by 2 into sine n minus 4 into x into dx. Again this is 0. 0 to pi by 2. 0 to pi by 2. Now this value will be 0 again. It is 0 plus nothing but n minus 3 upon n minus 2 into 0 to pi by 2 sine n minus 4, n minus 4x. It is sine n minus 4x dx. Now, so what do we get here? This is n minus 1 upon n, then n minus 3 upon n minus 2, and again the value will increase. So what is the the series we obtain here. Now let me write it in the same series. This value will be 0. These are, whenever cos x sin x will come, they will be pi by 2 limits, if we substitute, then this part will be 0. This portion of, this integration will be 0. Only this n minus this symbol, if I write symbolically, then what the final result, if n is odd, if n is even, that we have to find out. Now let me calculate that value. It is equal to, let me write, n minus 1 upon n finally, into we see here n minus 3 upon n minus 2, into n minus 5 upon n minus 4, etc. What is the last result of this? Okay, now let me write here, this is sign of integration of 2, and sign of integration, if I write here, then what is this symbol? This is n minus 5 here. Here it will be n minus 6. 0 to pi by 2. Sine it is equal to n minus 6 x into dx. Now here we have used n minus 2, n minus 4 by there, n minus 4, n minus 6 by there. So in this way, we can write this series. So what is the final result of this then? What is the final result of this? So in this way, there are two cases arising. What is the two cases? Now, case number 1. When n is an, let me take first odd number. N is an odd number. N is an odd number. One case. If I write n is odd number, suppose this is any odd number. This is suppose n minus, or let me take n 7 here, no problem. The last term will be what? Here it will be, then all these terms, the numbers will be there. N minus 7 is, it will be 6 upon 7, 6 upon 7, then 7 minus 3 is 4 upon 7 minus 2 is 5, so 7 upon 6 like this, series will increase. So last point will be what? That we have to think about. In case of odd numbers, it will be 7 minus 6 means sin x only. Integration of sin x will be minus cos x. So integration of sin x. So the last result, in case of when n is odd, the last integral will be what? 0 to infinity, so 0 to pi by 2. It is sin x only. So last value will be only sin x in this case. In case of this one, only sin x will be there. What is the result of this? The last integral or last term, or last term will be, the last term will be this. In this case, if n is odd number, this case is when n is odd number, then what is the last result of this? The last result will be when 0 to pi by 2 sin x will be the last term. If I after integration will be minus cos x, or sin x integration will be minus cos x, then we have to substitute the value here, 0 to pi by 2. So at pi by 2, the value will be 0, because cos pi by 2 is 0. But at 0, the minus lower limit will be substitute, we put minus sign in between. The minus is minus sign, and the cos is 0, will be plus 1. The last point will be plus 1. Okay, so in this way, if I substitute these values, the last result in this case will be 1. When n is odd, let me write the final result. In this case, the final value, if n is, sorry, in case of, we have taken here n is odd, then sine of integration 0 to pi by 2, sine is called nx into dx, will be equal to n minus 1 upon n minus 3 upon n minus 2, n minus 5, okay, upon n minus 4, and so on. The last value will be 1 into 1. And before that, what will be there? 1 upon 2, because even number is there. Odd number minus this will be odd number here. Okay, so this is 1 here. And before that, let me take the sin x there. If it is only sin x here, suppose, then what is the previous value of this? Before this 1, we have to take, okay, let me take this as sin x. This is 1 power only. Okay, so here we have to substitute what? N minus, here it was 1, power was n minus, this difference is 1. That means if I write here, suppose 7 minus 5, 2. Here 7 minus 4 will be 3. Okay, 7 minus 4. 9 minus 5 will be 2. So this is 1 point. So 7 minus 5, 2. Here 7 minus 4 is 3. 2 by 3 in the last point will be 2 by 3. 2 by 3 into 1. No other value. Okay, 2 by 3 is suppose 7 point is there. Any odd number we can substitute here. 7 minus 5, suppose it is 2. In the numerator and denominator we have 7 minus 4. That means 3. Okay, because other point will not be there. So next will be 7 minus 7. That cannot be there. So it is 0 then. Only last term will be 2 upon 3. Because that this is 4 upon 5. Etc. It is 4 upon 5. Why then 7 minus? Okay, before that, if I write the previous number, then this 7 minus 3, 7 minus 3 is 4, 7 minus 2 is 5. This is the next result. I mean, last result of this series will be 4 by 5, 2 by 3 into 1. 1 is integration of sin x into dx. Alright, this is the final result of series of this when n is odd number. If n is odd, then this is the final result. This is the first result of this. We'll substitute this value here in this way. So if I take n is odd number, now let me take when n is even number. When n is case number second here. Case number second when n is an even number. Then in that situation, the same series will come out. What the last result? The last value will be here 0 power, because we write n equal to 4 6. Suppose 6 is there, even number is 6. 6, 4, 2 and 0. Last result will be sin of integration 0 to pi by 2. It will be sin e power 0 into x into dx. But here it is sin 0 x into 1. It is nothing but 0 to pi by 2 into 1 into dx, that means dx only. The last, let me write here. The last result or last term of this integral will be this one. Okay, the last result of this will be this one. That means x only limits 0 to pi by 2. The last will be pi by 2 only. You have to multiply the last value by pi by 2. So what is the, suppose I take 6 here. 6 months last value will be 1.2. 1.2 into this 3 upon 4 like that. So the value, the series will be, in this case if I write, let me write the last value. So it will be pi by 2 in the end. Before that it will be 4. Okay, okay, let me write here 6 minus 5 is 1. It is 6 minus 4, 2. And then 2 minus 2, 0. Okay, the last will be 6 minus 4, but last point will be 0 power. That is this 1.2 here. Okay. So and the last there will be 3 by 2. Okay, here it is 1.2, and before that, if it is suppose 6 b2 3 3 by 4 3 by 4 here. Okay. For 6 are taken. 6 minus 1 5 5 by 6 etc. In the denominator we have even numbers 2 4 6 etc. will be increased and maybe infinite number, but even number is this is a series of numbers. In the end we will get pi by 2. That is what we have obtained. Okay, so these are the two formulae. So let me write here. When n is odd, when here, okay, when n is even. In both the cases, the two results will be. Let me write here. So the same result will be in this case also. The same result will be here. In this case, it will be okay. If n minus 1 upon n minus this is n minus 3. Okay, n minus 3 upon n minus 2, n minus 5 upon n minus 4, etc. And last result, if n is odd, okay, and last result was 1. Why 1? Because cos x by subtract 1. It was 1 here multiplied by 1 in case of odd number. If it is even number, then cos nx, second formula for that we take for sin nx, when n is even number. When n is even number. When n is even number, then what is the result? In that situation also, when n is even number, the sin nx dx is equal to, again we will write the same thing, same symbols, n minus 3 upon n minus 2 into n minus 5 upon n minus 4 and so on multiplied. Okay, and last will be pi by 2. In case of even number, last result will be pi by 2 because x is the integral of sin equals 0. But in case of even number, last is this and 2 minus 2 0. Okay, and also that will be 0. 0 means sin 0 is 1, so integration of 1 or dx is x. Substituting the limit here pi by 2, the last point will be pi by 2. Before that it was 1.2. Okay, because if I take 6 here, this is 1.2 here, then 3 by 4 here, etc. These are the ending terms here. So these are the two pieces, two formulae for sin nx. Now let me talk about cos nx. Even for even number sin nx, this first question I've taken here. Let me talk about the second question. Question number second here, cos nx. That will also have the same type of valuation. You will pi by 2 yes. Now let me define it. We came to know about that. What is that? We express this cos n minus 1 into cos n minus 1 x into cos x. Cos x was integrated, was second function, it was taken as I just discussed about. Okay, the reduction formula, the same reduction formula here also will be used. In the previous lecture, I talked about reduction formula for sin power nx and cos n for power nx. Okay, so I gave them as, but here it is positive value. With that, sin x, okay, because cos x integrated is positive sin x into cos n minus 1 x upon n here plus n minus 1 upon n is being used about cos power n minus 2 into x into dx. This is the formula for cos nx into dx. Okay, now this further is simplified and the second part is 0 to, let's write 0 to pi by 2. Here also 0 to pi by 2. I'll just define that. What is the value? 0 to pi by 2 and this cos n minus 2 into x into dx is equal to again sin x. Okay, it is sin x, it will be cos n minus 3 into x upon n minus 2 here, this power will come in denominator, plus n minus 3 upon n minus 2 extent of integration 0 to pi by 2 into cos power n minus 4 into x into dx, etc. Now let me talk about, with this series we will just talk about this and limits 0 to pi by 2. What are these terms here? If I substitute pi by 2, this is 1, okay, sin pi by 2 is 1, cos pi by 0, cos pi by 2 for simple integers, x is multiple of integers, okay, this will be 0 then. So, I mean, cos pi by 2, it is odd numbers, for example, then this is 0, cos pi by 2 is 0, and when 0, when sin 0 is 0, this value will be 0, in that situation, 0 here, 0 plus only this n minus 1 upon n is 0 to pi by 2 into cos raised power n minus 2 into x into dx. With this value is this. Again, this will be this is 0 again, pi by 2 if I substitute here for regular integers, I mean odd number integers, in this case multiple, x multiple is just n minus 3 is an integer, but substitute here integers, so cos x, cos pi by 2 0 for I mean value of x is pi by 2, cos pi by 2 0, whatever power is there, that be 0. This case it is 0 also. It becomes 0 plus n minus 3 upon n minus 2. It is 0 to pi by 2 into cos raised power n minus 4 into x into dx. Similarly, we can extract this. Okay, so let me take the case number 1 here. In this case, also case number 1 and case number 2. Let's talk about case number 1 when n is an odd number and n is an odd number. In that situation, what is the last term? Last term will be, let me write it here. So what is the last term? We have just taken when case number 1 I'm talking about, case 1, when n is an odd number. When n is an odd number. In that situation, what will be the value of this? This will be n minus 1 upon n, again n minus 3 upon n minus 2, n minus 5 upon n minus 4,